Okay, let's see. Has Sunil sir given you the corrected papers or not?
Yes, sir, we got it.
Got it? Okay, you got it in the PDF itself? He has corrected it, or how does?
He sent, like, he took pics of it and using WhatsApp, like using the pen and WhatsApp, he corrected and then gave it back.
Okay, I thought he's using some app in the, you can correct it in the PDF itself.
Yeah, that we can do, sir. Adobe PDF and all that.
Okay. I thought he's using that. He's not using that.
Last time, I guess he used that, but this time for me, I'm not sure about the others. For me, he sent it.
Okay. Okay, so we are supposed to get started with the motion in 2D, right? So if you have studied motion in one dimension, most of the concepts are going to be applied over here also. Okay. So let's get started. Share. Okay, share screen first. Okay. Okay. So in chapter 4, mainly we are going to focus about motion in 2 dimension, right? So Elvin, I tried giving you recording permission, but that option was not there. So allowed to record. Okay, yeah, now it's there.
So it's already recorded.
Yeah. So listen carefully. So in chapter 4, we are going to study motion in 2 dimension. Okay. So either you can say motion in 2 dimension or you can say motion in a plane. Okay. So as I've been telling you, the previous chapter we studied 1 dimension, which is something like a straight line. But now we'll be studying more of a motions in in a plane, something like a carom board or a billiards, balls moving in a board, right? So those kind of things. But whatever you are applying here, you can apply it for 3D also. Okay. So first of all, you know something about vectors. So suppose if I say I have 5 Newton this way, and if I had say 3 Newton this way, right? So what does this mean? The tails are touching each other, right? So imagine that I have a ball here. One guy is pushing it 5 Newton this way and another guy is pushing it 3 Newton this way. So which way the ball is going to go?
Newton side, sir.
Hmm?
5 Newton.
5 Newton.
It
Really?
won't go exactly, sir. It'll
Hmm.
go, but it'll go more towards the 5 Newton side. But there'll be little bit of vertical.
Yeah. So that means it's going to go somewhere here. Okay. So what you're trying to say is 5 Newton is bigger than 3 Newton. So that means the influence of 5 Newton is going to be bigger compared to 3 Newton. But still you have to understand that it's going to go somewhere here, which means it's going to have some 3 Newton effect and 5 Newton effect. You're unable to imagine what I'm saying?
Yes, sir.
And this is what we mean by vector addition. So the first step is the tails should be touching each other. Okay, so take it down properly. So only when the tails are touching, right? I'll be taking this leading diagonal and we call this as the parallelogram law of vectors. Okay. So suppose if I want this is nothing but your hypotenuse in this particular case, because this is 3 Newton means this is also 3 Newton. This is 90 degree. So that means this is something like your hypotenuse side. So that means R here is square root of 5 squared plus 3 squared, which is your 25 plus 9, which is 34. So root of 34, whatever that is. Okay, 34 Newton. Something close to 5 point something, right? 36 is 6, so 34 will be 5 point something. Any doubts here?
5.83.
5.83, okay. So that means this is what is we called as resultant. Okay, resultant force. But what if I had the forces acting in an angle? So this is 5 Newton. Here the angle between them was 90 degree. Here I'm going to say that 3 Newton is acting in a certain angle. Then also, right, very interestingly, I can use the same method. So construct a parallelogram. And this is what is your leading diagonal. So when the tails are touching, right, when one ball is acted upon by two forces, it's going to go this way. And this is what is your resultant. Okay. Again, this is what is called vector addition or parallelogram law of vector addition. So take it down. Parallelogram law of vector addition. So we have a very simple derivation, nothing very difficult. So quickly follow this. So suppose if I say, again, for just for understanding, I'm giving you numbers. Okay. In theoretical questions, when you're writing in the exam, you're not supposed to use these numbers. Okay. So it's only for
So
your
1 minute
understanding.
can you spell? Yes.
So now here it was 90 degrees. So it was easy for me to use the Pythagoras theorem, right? But here it is not a 90 degree, which means I cannot use the Pythagoras theorem. Okay. Instead, we have to use another formula. So take it down. So we have a small method here for our derivation. So let's say this is my A vector. Let's say this is my B vector.
Sir, you're in the new chapter, sir. Motion plan.
Yeah. Why are you so late?
Actually, there was a confusion between the links, sir. Actually, I clicked the wrong link.
Okay. So if I say this is my resultant, okay. So what I will do is I will, if this is B, this is also B. Okay. And let's say the angle between A and B is theta. So between A and B is theta means this is also A direction and this is B. So that means this is also theta. If this is B magnitude, right? This is adjacent sides, which means B cos theta. This is opposite side, which is B sin theta. right? Opposite means b sin theta, adjacent means b cos theta. Okay. So now carefully look at it. If you consider this bigger triangle, right? This is a 90-degree triangle. Do you agree? It's a right triangle. So that means
Yes, sir.
I'm looking at this side and then this is a right triangle, which means again I can use the Pythagoras theorem. So that means the Pythagoras theorem is resultant is equal to, look at this. I have to take this total length, which means a plus b cos theta, the whole square, plus this length, which is b sin theta, the whole square. Square root. So simply I'm using the Pythagoras theorem. Anybody not following this, please raise the question immediately. So this length plus this length, b cos theta, and then this height, so b sin theta. Anybody? Any doubts? So that means I can use a plus b the whole square, which means a squared plus b squared cos square theta plus 2ab cos theta plus b squared sin square theta. So I can see b squared here, b squared here. If I take it out commonly, sin squared plus cos squared. What is sin squared plus cos squared?
1.
1. A squared plus, so sin squared plus cos squared becomes 1. So what is remaining is 2ab cos theta. That's all. So this is an extremely important formula. Okay, every time whenever it is vector addition, you're going to be using this formula: a squared plus b squared plus 2ab cos theta. So that is your magnitude, resultant magnitude. If it is a vector, is it sufficient for me to tell the magnitude, or should I say, tell the direction also?
Magnitude only.
Magnitude only.
Only magnitude. If it's a vector, can I say, okay, the resultant is 10 units this way? Will it be correct with this data? The resultant is a vector, right? That means magnitude alone is not sufficient. I have to give the angle also. So what is the angle, or which angle it is acting? Everyone following what I'm saying? So it means vector means you have to
Yes,
give
sir.
the angle also. So it means, again, I'm going to look at this big triangle, okay, right triangle. So tan alpha is equal to opposite by adjacent. What is opposite? B sin theta. What is adjacent? A plus b cos theta. That's all. So it means tan alpha is equal to b sin theta divided by a plus b cos theta. That's all. Carefully understand, theta is the angle between a and b. Alpha is the angle between a and the resultant. A resultant magnitude can be shown something like this. R is a vector, but then if I put a modulus symbol, it is magnitude. Whereas this is tan alpha is the angle between the R and A. So usually it is the A is the first vector, B is the second vector. So that means the alpha, you should say that angle between the resultant and the first vector. Any questions? Very simple derivation. Very simple derivation. Okay. If you have any doubts, please clarify right now. Now in this case, right, in the very first case which I showed you here, what was the angle? What was the theta here?
90 degrees.
90 degree. So if I substitute it over here, cos 90 becomes
1.
no
0, sir.
0, 0.
0. Cos 90 becomes 0, which means this entire term will go away. Which means what will you get? A squared plus b squared, and that's what you got here. A squared plus b squared. So it means 90 degree is a special case. So take it down. In physics, very often we are going to be studying special cases. Okay. So the special cases will be theta is equal to 90 degree, meaning A and B are 90 degree like this. Which means the resultant is going to be square root of A squared plus B squared. How do you know that? Resultant magnitude is A squared plus B squared plus 2AB cos theta. Cos 90 becomes 0. What happened here? Okay, so cos 90 becomes 0. Okay, so this is nothing but your usual Pythagoras. So this is special case 1. What if I said the angle is 0? What is the meaning of that? A is here. Something wrong with my mouse pen, so just a sec. The point has become very small. A vector is this way, B vector is also somewhere here. So that means the angle between them is 0. Everyone following this?
Yes,
So
Yes, sir.
if I say this is 5 Newton and this is 3 Newton, what will be the total effect?
Cos 0 is 1.
Okay. What will be the total effect? Forget about cos and all. If you
Sir,
one guy is
it
pushing
should be 0, sir.
0, angle is
I
0,
think.
sir. I'm asking what is the resultant? One guy is pushing with 5 Newton, another guy is pushing with 3 Newton. What will be the total?
8 Newton.
8 Newton. So that means it'll be the effect will be 8 Newton. Okay, let's see if this formula gives you the correct answer. So the R magnitude is equal to A squared plus B squared plus 2AB cos theta. Cos 0 is 1, right? Which means 2AB. So A squared plus B squared plus 2AB becomes A plus B the whole square. So what will happen? The square and square root will cancel. So what you will get is A plus B. And that's why you are getting 5 Newton plus 3 Newton is nothing but 8 Newton. Everyone following that? Very simple. So whenever theta is equal to 0, this goes away and you can directly add this and this because it's in the same direction. So this is your second case. What will be any other special case? We talked about 90 degree, 0 degree. Any other special case which you can think of? That's all. Can the vectors be acting in the opposite directions?
So what about cos 60 and all?
Cos?
Cos 60.
Cos 60.
Yeah.
Cos 60 I would not consider it as a special case.
So
What about forces acting in the opposite direction?
180 degrees, sir.
180 degree, yeah.
It is possible, sir.
Yeah, it's very well
Maybe
possible.
twice 90.
So theta is equal to 180 degree. What does that mean? A vector is this way, B vector is this way. So somebody is pushing this way 5 Newton, somebody is pushing this way 3 Newton. So what will be the net effect?
So it'll be 2.
2 Newton.
If 5 was in the
Yes,
other
sir.
side, it would have been -2, I guess. So.
Yeah. So, but when you're drawing you show the arrow, it's already taken care, right? So it's saying that it's going to go this way. Okay. So how did you get that? So R magnitude is equal to a squared plus b squared plus 2ab cos theta. This is cos 180. Cos 180 becomes
Minus 1.
1. So minus 2ab. A squared plus b squared minus 2ab becomes a minus b the whole square. Something wrong with my mouse pen. So the square and this will cancel, so I'll be getting a minus b. Okay, and that's what we did over here. So that is another special case. Suppose, like what you said, suppose if this was 3 Newton, this was 5 Newton, then it will be a minus b. So 3 minus 5, so it will be minus 2, which means it will be in the opposite direction.
270 and 360 are similar to the other ones only. Because 360 will give 0. Cos 360.
Yeah.
This will give 1.
Yeah, so it's very similar to 90 degree. 270 is similar to 90 degree. So you can skip that. Okay. Anybody not following this? We talked about the magnitude, or we forgot to talk about the angle, right? So the angle here, listen carefully. If I go back to the very first example, this is the alpha. That is the angle. So if I want this alpha, what should I do? I can do tan alpha is equal to opposite by adjacent. So 3 by 5. So it means if I want alpha, tan goes to the other side. So tan inverse of 3 by 5. Okay. Don't get confused by this. I'm sure you are studying a little bit in your mathematics. So if I say tan 30 is, if I say tan 30 degree is equal to 1 by root 3. If the tan
Sir,
comes here,
be possible, sir.
what's your question?
Sir, how can tan go to that side, sir? And
That's what I'm trying to explain. Okay, maths, as I told you, all these things are mathematics. Okay, so when the tan goes here, what it means is for this value, what is the angle? Or in other words, tan inverse means which angle will give me this value. That's the meaning of this. Okay, so that means 30 degree is equal to tan inverse of 1 by root 3. That's the meaning of this. So that means this value will come around 30 degree angle, right? So that's the meaning of this. Okay, so take it down. As you study in your mathematics, it will make more sense. Okay, so without studying it in maths, it's not going to make 100% sense right now. So coming back to this, I told you tan alpha is equal to b sin theta by a plus b cos theta. So in the first case, tan alpha is equal to b sin theta divided by a plus b cos theta. And what did I say? Theta is 90 degree. So sin 90 becomes 1. Cos 90 becomes 0. So this term goes away. This becomes b into 1 is b. So tan alpha is equal to b by a. And that's what you got in the example which I showed you. So alpha is equal to tan inverse of b by a in this particular case. Similarly, if I have sin alpha, I can bring the sign on this side. I will say sin inverse or cos inverse, something like that. Okay, I should have written it over here. I think I wrote it here. So along 90 degree, I have to get this. So you take it down properly. Similarly,
Okay.
I can.
Can we finish that writing, please?
Which one? This one?
Yeah.
Copied.
1 second.
So the next case will be theta
Yes.
is equal to 0. So substitute theta is equal to 0 here. Tan alpha I can write it in the red color, is equal to b sin theta divided by a plus b cos theta. Sin 0 becomes 0. So that means this entire thing will become 0. So tan alpha is equal to 0. So which angle gives you 0 in tan? Anybody? Tan 0
Tan-
is
Tan 0.
so 0 degrees. So that means when this tan goes here, right? So if you want 0, then I should say alpha 0 will give me tan 0. Okay, tan 0 will give me 0. So that's the meaning of tan inverse. So when you take the tan inverse, what it means is which angle will give me that particular value. That's the meaning of this. So alpha is equal to 0. What does that mean? The resultant is along the same line. That's the meaning of this. Everyone following?
Yes, sir.
Chaitanya following the tan inverse thing?
Yes, sir. Able to understand.
Okay. Now let's go to the next one.
180.
180, right? So same formula, tan alpha is equal to b sin theta divided by a plus b cos theta. So sin 180 becomes, what is sin 180? Don't know. So sin 180 is also
0.
0. Okay. Cos 180 is minus 1. Sin 180 is 0. So that means 0 by anything is 0. So alpha will become 0 again. So that means the resultant is along the straight line here. Okay, so that's the meaning of this. Any questions? So what have we done so far? We have done nothing. We have just understood what is vector addition. And the most important formula is square root of a squared plus b squared plus 2ab cos theta, and then tan alpha is b sin theta by a plus b cos theta. If you understand this simple diagram, right? Let me tell you this. Even when you go to your 12th standard, again and again, you'll be using this. Okay, when you go to college or 12th standard, wherever you go, you'll be using this concept. Okay, so you have to remember this vector addition concept, tan alpha and resultant. So this and this you have to remember. If you don't remember, then you have to immediately quickly draw this and arrive at this. If I forget this, I will say, okay, I will draw this and I can say tan alpha is opposite by adjacent. So b sin theta divided by a plus b cos theta. That's all. So this is what we have done so far. So vector addition is what we have done so far, and we have studied 3 special cases. That's all. And this is what is called law of parallelogram law of vector addition.
Sir, can you show the 90-degree alone one, sir?
This one.
No, sir, the first one.
This one.
Yes, sir. Just a minute, sir.
Sir, and one more thing, sir. Before teaching this addition of this vector, sir, did you teach anything else, sir?
No, this is the starting point. Starting with this, ijk will come to that vector. Coordinate system of vector addition will come to it later. Okay. Okay, so far we have talked about vector addition. Any doubts? Very important. And for some reason, students think that it is difficult. There is absolutely nothing difficult here if you understand the concepts. Okay. Now let us talk about vector subtraction. Just for simplification, let's say I have a vector along this way, and I know that b vector is this way. Suppose, let's say the b vector which we assumed earlier was this way. I'm going to say that if there is a vector this way, right? If I say this is a vector, then I can say that minus a vector is going to be opposite to this. So if something is going this way, if you take just straight opposite, then that is your negative of this. Okay, and that is your opposite. So which means this will be 180 degree. Okay, so with that concept, I'm going to say that if I want minus b vector, I'm going to draw it this way. Anybody not following? If you take the opposite, that is your minus b. Luckily, I already studied vector addition. So instead of doing a plus b, I'm going to do a plus minus b. If I do a plus minus b, what will happen? This is nothing but a minus b, which means by using a simple trick of opposite vector, right, or negative of a vector, I can simply do the same vector addition. Only thing, instead of a plus b, I will be doing a plus minus b. So that means this is your a vector, this is your b vector. Somebody is pushing it this way, somebody is pushing this way, which means the billiards ball which is kept over here is going to go this way. So if you ask yourself which way the billiards ball or the carom coin is going to go when two coins, two guys are pushing it at the same time, then it will go this way. So that means this is nothing but your a minus b. So take down these all concepts properly. Okay, so that is your a minus b. So what this means is, if I want a minus b resultant, right? If I want this magnitude, I can simply use this same formula which we found earlier, which is a squared plus minus b the whole square plus 2ab cos theta. So 2ab, actually since it is magnitude, I don't have to write the vector symbol. Cos theta. But then in place of b, I have to write minus b, right? So a minus b cos theta. Wait a minute, I think I'm making a mistake here. So this is 180 plus theta. So here I'll be writing it as magnitude. So this is just a magnitude. So this is also magnitude. But in the angle, right? So look at this. I'm going to be adding a and minus b. That's the addition I want to do. So a is the magnitude, b is the magnitude. So a squared plus b squared plus 2ab. Angle will be, it's not theta now. So this is your angle theta. So this is your phi. So instead of theta, let's call it as phi. So the angle between the two vectors is phi. But I know that phi is nothing but 180 minus theta. Do you agree? This is theta means this is 180 minus theta.
Yes, sir.
So that means this I'm going to write as, instead of writing it as cos 180 minus theta is what I'm supposed to write here. Because the angle between a and minus b is cos 180 minus theta. Cos 180 minus theta, anybody? What is it first quadrant or second quadrant or third quadrant? 180 is here. 180 minus theta means it is in the second quadrant. In second quadrant, cos is positive or negative?
Negative.
Negative. So all silver. Something wrong with my mouse pen. I don't know how to deal with this.
So try removing it and disconnect and do it again.
That's what I'm doing every time. I think the pointer has become very small, so I've been using it for a very long time. So 180 minus theta means you can assume that it is second quadrant. So all silver teacups. Silver teacups, right? So all angles sine, tan, cos. So sine is positive here, tan is positive here, cos is positive here. So that means cos is negative here. So that means cos 180 minus theta will become cos theta, but with the minus. So that means you will be studying this in your mathematics. Okay. So trigonometry, I think they should have started it right now. Okay, the very first chapter, I think. So it means whenever it is subtraction, right? Instead of plus, there will be a minus here. And remember, theta is the angle between A and B, not minus B. Okay, minus B is only for our understanding. We are doing it like this. But if I want to find the A minus B, right, I will still have to consider the theta between A and B. Now, can anyone tell me this red line, which is shown here, which is given as A minus B? How can I show that in this yellow lines? Which line is it going to be? Is it going to be this line or is it going to be this line? First one or the second one?
I think it's the first one, sir.
First one, sir.
The first one is going this way.
Second one, sir.
Second one. Okay, look at this.
Second one is opposite
Look at
side.
this line and this line. Okay. So that means this line is same as this line. So that means if I want to show A minus B, right, I'll be showing here. Okay. This is only for your understanding right now for the derivation. But usually in our diagrams, we'll be showing A minus B this way. So take it down properly. And similarly, I can draw something like this. So if it is this way, right, the opposite direction, I will call this as B minus A. Why? Because if it is coming this way, if it is A minus B, if I put a minus here, minus of the bracket, it will give me minus A, minus of minus plus. So that means it will become B minus A. So opposite of this vector will be B minus A. So easy way I remember is final minus initial. Look at this arrow. It is coming to A, but it is starting from B. So that means final minus initial. Look at this arrow. It is coming to B, but it is starting from A. So that means B minus A. Okay, so take it as final minus initial. So that is what is your vector subtraction. Okay, so very often we are going to do vector subtraction. Okay, whenever it is vectors, you should not do scalar subtraction, you should do vector subtraction. Okay, so I gave you how to find the magnitude here, right? So A minus B, this is the formula. Only thing, instead of plus, you will be getting a minus. How to find the angle between this and this, right? So let's say this is my alpha. So let me redraw it. Maybe in your case, maybe you don't have to redraw it if you are taking it down properly. So this is your A vector. This is your B vector. This is your angle theta. And let's say this is my A minus B. And let's say the angle between the resultant and the first vector is your alpha. Okay, so the direction which I want. So I know the magnitude over here, right? So A minus B magnitude. I know the magnitude here. So what I can do here is, listen carefully. I can make a line over here. So if this is B and this is theta, this will be B sine theta. Okay. And this will be B cos theta. So that means in the vector addition case, right, if you remember the diagram, you got a diagram like this. And then I drew another line over here. Why did I draw this? To make a right triangle. So this was B and this was B sine theta. This was B cos theta. And then this was A. So similarly here it is B sine theta.
Excuse me, sir. Hello.
So everyone following this? Anybody got the tan alpha? Tan alpha is equal to anybody?
So, your voice, we couldn't hear you, sir.
Okay.
Like for 3-4 minutes, we couldn't hear you.
No, that was, I just muted myself.
Okay.
Can you hear me now? Everyone, can you hear me?
Yes, sir.
Yes,
Okay.
sir.
So tan alpha is equal to opposite by adjacent. Okay. So what is opposite? B sine theta. What is adjacent? This part alone. What is this part alone? The total length is A,
Yes, sir.
and this is B cos theta. So it means it will be A minus B cos theta. So here, if you see, it was plus. So the alpha here was B sine theta divided by A plus B cos theta. Here, if you see the diagram, right? Everyone following this? I want only this length. If I want only this length, it's nothing but A minus A minus B cos theta. Yeah. Anybody not following?
Following, sir.
So my suggestion is when you study vector addition and vector subtraction side by side, it will make a lot of sense. Okay, you will understand why you are getting a minus here. Even this formula, right? I could have derived it from here. So if I want this, right? You see, this is the right triangle, which means I can use the Pythagoras theorem. So that means I can say A minus B, the magnitude, is nothing but A minus B cos theta, which is the bottom part, the adjacent side, whole squared, plus B sine theta, the whole square. Again, you will get the same thing except for the minus 2AB, because you have minus here instead of plus. So that means you'll be getting A squared plus B squared minus 2AB cos theta. So I think this is easier derivation. So take it down. Okay, maybe this is also good for you to understand that, you know, B is coming like this, and then you are doing the minus B. But then you have to be convinced that why we are taking this as A minus B. Only if you know this diagram, right? This will make sense. That's why I wanted to show you this diagram. Okay, so maybe you don't have to worry about this red part. This derivation is better. In your textbook, sometimes they don't give you the vector subtraction, but I would say it's very important. Okay, so very often you'll be doing vector subtraction. For example, in the previous chapter, we studied relative velocity. So we said VA minus VB. So there we said 60 km/h minus 40 km/h. So why did we do that like that? Because we assumed that the cars were going in a straight line. But what if the cars were going in, different angles? So one guy is going towards Tirupur at 60 km/h. Okay. Another guy is going towards some other direction, say towards Ooty at say 40 km/h. Okay. So now if I say this is A and this is B, if I asked you what is the relative velocity between A and B, so take it down, very important application for your vector subtraction. Okay, so take it down. Application of vector subtraction. So if I asked you what is the relative velocity of A with respect to B, right? I will write the same thing. VA B is nothing but VA minus VB. But is it okay if I did 60 minus 40 here? Is it okay or not okay?
So I guess it's okay if the angle is 90 degrees, sir.
90 degree, like this. One guy is going this way and one guy is going this way.
Yes.
No.
But actually, they both have to be in same direction, right, sir? So
Yeah.
I don't think so, sir.
Okay. So everyone listen here. So what you said is correct. So in this case, we look at the diagram. Is the 60-kilometer A and B cars going in the same line, or are they going in 90 degree?
The same line, sir.
Only when they are going in the same line, right? This was uniform straight line. Uniform, it was going in a straight line, right? So in that case, you can do 60 minus 40. But now we are talking about planar direction. So I said this guy is going towards from Coimbatore. Let's say this guy is going towards Tirupur, and this guy is going towards Ooty or somewhere. So that means if I asked you what is the relative velocity of A with respect to B, right? I should not be doing this one. So this is wrong. However, this equation is still correct. Only thing you have to put this thing. So if you write it like this is correct. Why? Because now it becomes vector subtraction. So when it is becoming vector subtraction, VA minus VB, and if I know the angle between this road and this road, let's say this is 60 degree, right? So that means I can say the velocity of A with respect to B is nothing but VA minus VB, which is given by this formula which we studied right now. So that means the magnitude for this, how do I write the magnitude? Write the entire thing and then write it like this, or if you want you can write it as so A squared plus B squared, right? So 60 square plus 40 square minus 2AB cos 60. Cos 60 is 1 by 2, so 1 by 2 and this 2 will cancel. So what is left is 60 squared plus 40 squared minus 60 into 40. So anybody have the answer for that? 3600 plus 1600 plus 6 4 so 24. Sorry, there is a minus here. So there is a minus. So minus 2400. So 36 minus 8 means 2800. Is that correct, everyone? 28 will give me 5 point something. 100 square root is 10. So
52.91, I guess.
52.91 kilometer per hour. So that means the magnitude of this relative velocity will be, this guy is actually going at us away from B. He's going 52 kilometers per hour. That's the meaning of this. Okay. And who will give the angle? If I give only the magnitude, that is not sufficient. So that means alpha is equal to tan alpha is equal to B sine theta divided by A minus B cos theta. B sine 60. So B is 40 kilometers per hour. Sine 60 is root 3 by 2 divided by A is 60 minus B is 40. Cos 60. Cos 60 is 1 by 2. 1 by 2 means this will become 20. 60 minus 20 will become 40. 40 will cancel. So sine 60 will become root 3 by 2. Root 3 by 2 is somewhere around 0.8. So tan alpha is equal to root 3 by 2. So alpha is equal to, in exams, if you don't know how to find this, you can leave it like this. Okay. So some examiners might reduce some marks because they expect you to find the angle from your calculator or from your data book. Okay. So anybody can tell me the angle for this? Root 3 by 2 is 0.8. 0.8 means something close to tan 40, I think. Tan inverse, so tan 40 is something close to 0.83. So that means I'm going to say the angle will be something close to 40 degree, 38 degree, or 39 degrees, 40 degrees. So it means the angle between this road and this relative velocity line is 38 degree. Vector addition is very often we'll be using. Vector subtraction rarely will be using, okay, but still very important. So that means whatever you studied in the previous chapter, it's the same thing. Only thing you should put a vector symbol and then you have to do the vector addition or vector subtraction. Take it down quickly. If anybody is copying, take it down. Any questions, any doubts? So I think everything is easy, nothing very difficult so far. Okay, everyone copied? Anybody still copying? Okay, so okay, what else is an important topic here? Let's see. So vector addition and vector subtraction for sure. Okay, so now that you know vector addition and vector subtraction, let's take a simple problem here. Let's say there is a river here, and one guy is trying to cross the river. Okay, so he's swimming like this. So he thinks that he is swimming this way, but then the river motion is also pushing it this way. So the velocity of the river is going to be, let's say, 5 meters per second. And let's say this guy is able to swim at the speed of velocity of the man. Let's say he's able to swim at the speed of, say, 1 meter per second. Okay. So now tell me, as he swims, will he be reaching this point, or will he be reaching this point, or will he be reaching this point? A, B, C.
C,
sir.
sir.
C, right? So it's quite obvious that he might be thinking that he is going straight, right? But when he reaches here, he will not be reaching here. He would have reached here. Okay. Suppose if there was a bridge over here and you were standing here, you will see that even though this guy is swimming straight, because of the reverse push or the current of the river, right? He will get pushed this way. Okay. So what's happening here is velocity of the man is 1 meter per second. Velocity of the river is 5 meter per second. So that means this you have to show it a little bit bigger. This you have to show it a little bit smaller. So that means this is your velocity of the river. Velocity of a man is equal to 1 meter per second. So that means this is smaller, this is bigger. So that means my resultant is going to be somewhere here. So obviously you can do the math yourself. So r is equal to square root of 5 squared plus 1 squared. You can do it. What about the alpha? We can say this is, okay, again my mouse pen problem. Okay. So if this is 1 meter, this is also 1 meter, this is 5. So tan alpha is equal to 1 by 5. So that means alpha is equal to tan inverse of 1 by 5.
So R is equal to 5.099.
5.09. Okay. Listen carefully. Since the effect of the river is very high and the effect of the man is very low, right? He is getting pushed too much this way. So he's getting, this, he will go very far away from here. But what if the river effect was less? The man's effort was more. Then it will look something like this. Suppose, let's say if I interchange it, let's say the man is going at 5 meter per second, whereas the river is having a very small effect, 1 meter per second. Then look at this. Now, this man's effort is much larger compared to the river's effect. So that means the river is not going to push him too much. So that means he's going to land very close to this point. Okay, so take it down. You have to understand the differences between this and this. Okay, so whichever component is having a bigger effect, it's going to get pushed that direction.
Sir, how to calculate tan of such values, sir? I mean, how to calculate the measure of the angle theta? That is this alpha.
Tan inverse of what is 1 by 5? 0.2.
2.2.
So you should be using some.
Sir, is there any trigonometric formula?
Trigonometric table. Okay, you don't have a direct formula for this.
11.3031.
Trigonometry table. So you should be having a data book. Do you have some blue color data book, science data book?
But they didn't provide anything in school.
Then you have to keep on waiting. Okay, my suggestion is go to your nearest stationery shop, pay some 20 rupees or 30 rupees and buy a data book, science data book, okay, blue color book. Otherwise, you will be waiting for the entire year. Okay. So look at this. This is tan and this is the angles. These are all the smaller angles between 0 and 1. You will be having these things. So let's see if I can make this bigger. Okay, that is not correct. Okay. So right now we got tan 0.2. So look for 0.2 in the values here. So you see 0. So this is 0.0209. So this is 192. So that means, is it tan here? Okay, so tan. What did we get here? Tan 0.2. So tan 0.2 is going to be something close to 1 degree. 1 degree, 6 minutes or something close to it. Suppose if I say tan inverse of 45, right? Sorry, tan inverse of 1. You know, tan 45 is 1. So it means if you see tan 45 here, tan 45 is 1. But if I say tan inverse of 1, I should say 45 degree. Are you following it or not?
Yes, sir.
Following? So that means this is your angle, this is your values. So when I say tan inverse of a value, you should be looking for this value. So for example, if I say tan inverse of 0.13, I'll be getting somewhere close to 7 degrees. 7 degree 24 minutes. Everyone following that? So if you are only ISC folks, you are allowed to use calculator. Okay. So otherwise, all the others, you don't have calculators. So you have to use this kind of tables. So go and buy the tables quickly. Okay. So you know something about vector addition, how to apply it in a real life situation like this. Okay. So this I'm going to call it as type 1 problem. So take it down. Type 1 problem, because we will be doing vector addition. Okay. Here what is happening is the river is also pushing the man is also pushing himself forward. So that means two forces are acting on the same particle. So take it down. Two forces acting on same object, same body or object. Okay. If that is the case, you can use type 1, which is vector addition. Anybody having any doubts? The second concept is, suppose let's say there is rain droplets. Okay, so the rain is falling down, and let's say I am going in a bicycle. I'm sitting here in the bicycle, and then let's say I'm holding a umbrella. So I'm holding the umbrella vertically this way, and then the rain droplets are also falling vertically this way. Now my question is, the umbrella is perfectly vertical. Will I get wet or not?
No, sir.
No?
Yes, sir.
Yes?
Sir, if the air is in the opposite, the wind is in the opposite direction, the umbrella will.
Well, I'm not talking about any wind right now. So assume that there is no wind. So the water particles are just falling down vertically downwards. So my question for you is, as I go
faster,
You will
there are if you're riding the bicycle faster, there's a chance of hitting the probability of hitting the raindrops is more, sir.
Okay, that is absolutely
So-
correct. Any other answers?
you will get wet, sir, because when you're moving forward, unless the umbrella is in an incline, you won't get wet. Otherwise, if it's not in an incline, you'll still get wet, sir, because you're moving
Okay.
forward.
So suppose if I'm standing here with the umbrella, will I get wet or not when I'm standing?
No, sir.
No. So what makes the difference here?
So, bicycle, you're moving, sir, but you're just standing in normal case.
The motion.
Okay, so that means you are in motion. Okay, so that means since you are going in certain velocity, what's happening is like what I think Chaitanya, I think you are saying that. So that means if the particle is coming down like this, right? If you are coming inside like this, there is a possibility that before this water particle falls down, right? There is a possibility that your face will be touching this particle, depending upon how high you are going. If you are going in a two-wheeler with the higher speed, obviously you will get wet more. If you are going in a bicycle with the lower speed, you will not get wet so much.
Whereas we walk, there's very least chance of getting wet, sir.
Yeah, because the velocity is very, very low. And if you're standing, then you will not get wet at all. Okay, assuming that there is no wind or any other effect. Okay, so take it down properly. So now what happens here is the velocity of the rain will be shown like this. And the velocity of the man is shown like this. Now carefully look at this. Which effect? So suppose if I draw the vector diagram between this velocity of the man and velocity of the rain, right? So the velocity of the rain will be shown something like this. Very important. So take it down properly. Pay attention. So velocity of the rain is shown like this, and velocity of the man is shown like this. I told you the tails should be touching each other. Okay, so tails touching each other is an important step. And the interesting thing about vectors is I can move it wherever I want without changing the direction. Suppose if I had a vector here, I can take this vector and put it over here. Why? Because the magnitude is same, the direction is also same. So I can move it anywhere in the paper. Okay, that's the important property of vector. Now tell me, I think it was Siddharth. You said if you tilt the umbrella, you will not get wet. So will you be tilting the umbrella this way, or will you be tilting the umbrella this way?
Forward, sir.
Forward. Okay. Now look at the diagram. Okay. Will finding this vector addition, will it make sense? Or finding this velocity of the rain with respect to the man, will this make more sense? Which one will make more sense? Look at this and look at this and tell me.
So the other one, sir.
What is the other one, sir?
So rain to man. Man
Okay, to man.
rain.
Okay. So this vector addition doesn't make any sense here. The reason for that is, carefully listen. This velocity is on the rain. This velocity is on the man. So take it down. This velocity is on the man. Only when both the forces are acting on the same object or same body, right, we can do vector addition, and that is what I called it as type 1. When two different things are acting on two different objects, then the vector addition doesn't make any sense. So this kind of problems I am going to call it as type 2 problems. So take it down. Type 2 problems, we'll be doing vector subtraction. So whenever I say type 2, you should remember it is vector subtraction. Whenever I say vector type 1, you should remember vector addition. Two forces acting on two different objects. So when it is acting on two different objects, vector addition does not make any sense. Two different bodies. So that means, carefully take it down. So this will be velocity of the rain with respect to the man. You should put a vector symbol. So that means what this tells you is, listen carefully. If I was standing here, right, velocity of rain will be downwards and velocity of man will be 0, right? So in that case, the rain is falling with respect to the man, it is falling vertically downwards. But when you're going at a high speed, like the man, right, even though the rain particles are falling down, with respect to the man, actually they are coming in an angle. And that is what you meant by this is going to come into the face. So even though it is going to fall down, right? Since this guy is coming into the rainwater droplets, right? So with respect to this man, it is actually coming this way. Is that making sense? Anybody not following? So that means when they ask you what is the velocity of rain with respect to the man, this is what you're supposed to find. So V rain minus V max, sorry, V man. And if they ask you very often, they'll ask you what is the angle with the vertical. So this is your alpha or theta. So in this case, tan alpha is very simple because it is opposite by adjacent. So V man divided by V rain. Any questions, any doubts? Everyone following?
Yes, following.
Okay. So what did we see today? Vector addition, vector subtraction. And then we saw one application type 1 problem for vector addition, one application for type 2 problem, vector subtraction. And then we also studied that whatever you studied in your 1 dimension, you can apply it in the 2 dimension for relative velocity using vector subtraction. That's all we have seen. Okay. So please start studying now itself. Okay. All these things are very important. If you study this now itself, it will become easy. If you keep waiting until the last minute, it's going to be difficult. Okay, so thank you all. If you have doubts, stay back. Otherwise, you can leave. Thanks. Bye.
Thank you, sir.
Thank you,
Bye.
sir.
Thank you, sir. Thank you, sir.
Thank you.
So,
Thank
Yeah.
you, sir.
so I got 42 on 50 in my test, sir. So,
Okay.
but I lost in the first two questions. I lost a total of 10 marks, sir. So I should be getting only 40 on 50, sir.
Okay. Just can you
But
inform
while
Sunil?
yes, sir. But while doing the calculation, it's coming as 42, sir.
Okay.
I
Yeah,
don't know how
I'm not
it's
seen the PDF. Did he correct it in the PDF itself or?
He took individual photos and sent, sir.